All right, welcome back. We are on number 21. Number 21, make sure you have your red ready to highlight. Remember, we're highlighting important numbers and keywords. Roberto can lift 103.5 pounds. That is 0.9 times the amount his friend Vance can lift. All right, so important. We have 103.5 and 0.9. Circle that in red. And then it says that is 0.9 times the amount his friend Vance can lift. That is 0.9 times the amount his friend Vance can lift. This phrase, that is super important. That is a turnaround phrase, and we've talked about that before, so listen up so you can hear if you forgot. The turnaround phrase means instead of doing what seems obvious because it says the word times, we're going to turn around the phrase that is. We're going to turn around and we're going to actually use the opposite operation. So the turnaround means opposite operation. So even though it says times, we're going to be doing what? Division. So even though it says times, so let's take this and underline times as well. So even though it says times, this phrase, that is a turnaround phrase. And that means that instead of times, I do division. Okay? And division is yellow. So the phrase that is, we're going to use this arrow and highlight turn around. That's a turnaround word. So instead of using multiplication like we think because of the word times, it's the phrase that is means this is the amount that is 9.9 times the amount. So Roberto can lift this much, and that is a fraction of what Vance can lift. Oh, 0.9 is a fraction of what Vance can lift. So can Vance lift more or less than 103.5? Roberto can lift this, which was a fraction of Vance's. So Vance actually can lift more. All right, does that make sense to everybody? Vance can actually lift more. So we do division with that turnaround phrase. So we take the 103.5 and we put that as the dividend. And we divide it by the 0.9. Now that there's a decimal in the divisor, I have to get rid of it. So I multiply this one by 10 to the first power to get rid of that decimal. And when I did that, it became what number? 9. Okay, well, if I multiplied the divisor by 10 to the first, then I have to multiply the dividend by 10 to the first. So we have to do the same thing that I did in the divisor to the dividend. So when I multiplied 103.5 by 10 to the first, I just moved the decimal over 1 and I get 1035. The decimal will be at the end of that because it was between the 3 and 5, and now I've moved it one place because of 10 to the first. So it's right there. Okay, and now I do division. How many times will 9 go into 1? It won't, but it will go into 10. So it doesn't go into the 1. You put a little X there. But it does go into 10 one time. And 9 times 1 is 9, so I subtract that from 10 and I get 1. And then I bring down the 3. 9 goes into 13 only one time again. And I subtract that. And I bring down the next number. 9 goes into 45 exactly 5 times. And you're going to prove it and write proof. 115. So, is that reasonable? We're doing step number 5 right now. We solve the problem and make sure your answer makes sense. Is 115 more than 103.5? Yeah, so it makes sense. So how many pounds can Vance lift? 115 pounds. Pretty cool. The important phrase there was that is and times, because I was thinking it was multiplication, but the phrase that is a turnaround phrase, which means I don't do times, I turn around and do the opposite, which was divide. Okay, number 22. The Daisy Cafe served 18 liters of hot chocolate today. That seems important. Circle in red the 18. Each serving was in a cup that held 0.2 liters. Did the cafe serve more or fewer than 18 cups of hot chocolate? Well, the fact that we have the phrase each serving should tell you something. It should tell you that we are doing division. So think about this for just a minute. Did the cafe serve more or fewer than 18 cups of hot chocolate? So if, oh, hang on. This is confusing because they did it in liters and then they did cups. The Daisy Cafe served 18 liters of hot chocolate. Each serving was in a cup. Okay, that makes sense. That held 0.2 liters. So you're going to be doing division here, right? So if each cup held 18, or if each cup held 1 liter, then I would get 18 out of it, right? Because 18 divided by 1 would just be 18. But it holds way less than a liter, so you're going to get lots. You're going to get lots out of one of the liters. Because you only have to put a tiny bit in a cup. So you're putting a tiny bit in a cup. So you take your total, and you're dividing your total by your serving size. Do you remember that lesson? We talked about how to set these numbers up. The total divided by your serving size. So you're going to end up getting more than 18 because you're only pouring a tiny bit of a liter into each cup. So you're going to get more than 18 cups of hot chocolate. Let's do the division and see if we set it up right. So you take your total divided by your serving size. Our total is 18. And our serving size is 0.2. I've got a decimal in the divisor, so I have to move it, which changes it to a 2. Because you moved it once. And remember, so that was timesing by 10 to the first. So if you times the divisor by 10 to the first, you have to times the dividend by 10 to the first as well. So what is 18 times 10 to the first? Well, you just add a 0 or move the decimal once and it becomes 180. Okay? This is mental math right here. Because 2 goes into 1, no. 2 goes into 18 exactly 9 times. And when it's exactly and the rest are just zeros, it's just a 0 up there. Let's see if it makes sense. Is 2 times 90 180? Yeah, it is. So, was 90 more than 18? Yeah, so you can circle that in yellow. I was checking to make sure it made sense. So how many cups did the cafe serve? 90 cups. Pretty awesome to do your work like that. I love these types of problems as you think through and make these predictions of more or less. That's important. Turn the page to page 228. In page 228, we have a lot of practice, and I think this would be important for us to do because we are first going to need to make sure we remember how to multiply decimals together and how to divide decimals when they're in both places. So I think it might be fun for us to solve number 23. I'm going to zoom in on that. Number 23 says 5.1 divided by 6. This is like saying I only have 5.1 candy bars and 6 people want to share them. So they're not all going to get one. They're going to get a fraction or a decimal of one, right? Okay, well, we have to go through this process still. What do we do when there's a decimal in the dividend and not out here in the divisor? What do you do with that decimal? You move it straight up into the quotient. Okay. Does 6 go into 5? No. So you could place an X. In this case, I would place a 0 instead of an X because it's right in front of the decimal, right? So I just move on. How many times will 6 go into 51? 8 times, which would be 48, right? Yeah. So then I subtract, and I get 3. And in this case, do I say it's 0.8 remainder 3? No way. I drop down the ghost 0. So how many times does 6 go into 30? 5 times. And then my proof is right there. So the answer is 0.85. Circle that with pencil. Okay, let's try number 26. We're trying some more division. Number 26. Ready? There is a decimal in the divisor. Beep, 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 beep. So get rid of it. 1, 2. It's like timesing by 10 to the second. So we have to do 2 over here. 1, 2. Uh-oh. You can't move it twice without first putting a 0 in there. So then the decimal is right there at the end. So I'm going to rewrite this as 96 is the divisor. And the dividend is 4, 6, 0, 8, 0. Wow. The decimal would be at the end of that. If you want, you could put the decimal straight up into your answer, just in case we need it. Okay. This seems really hard, but really, what is 96 really close to? It's close to 100. And counting by hundreds is not too bad. So this is that double-digit multiplication skill. So 96 is not going to go into 4 or 46. So you put little x's. But it will go into 460. So that's what you're looking at. And then you use your 100 to make a close estimate. Well, 100, 200, 300, 400. Could it go one more? 500? That would be 40 too high. I think 5 would be too high. Let's try 4. So go to your original number and do 96 times 4. I'm just going to do it right here. It's 24. And then that 36 plus 2 is 38. 384. Could I get almost 100 more? No. So it's 4. And here's how I'll know for sure is when I subtract these. If the number is 96 or higher, then I did it wrong. Right? So you have to subtract, which means you're borrowing. I got 76 as the leftover, so good. I did it right. Then I bring down 768. Well, it's going to be a lot higher than 4. It's almost going to be double that, right? Because that would be 600, 700. I bet it's, should we try 8? Let's try 96 times 8. Do the math. I got 768. Well, good. That's exactly what I was looking for. So the 8 goes in the quotient line. Bring down the last number, which is a 0. And remember, there's just a 0 up here. So 96 goes into 0 times. So you don't have to do anything else. The answer is 480. Pretty cool. Okay. Now that we remember how to do how to do division, I think we ought to practice some multiplication, just so everybody's aware. Let's try number 28. Ready? Okay, when I multiply numbers, I look for decimals and zeros. So I've got both up here in the first number. So I draw a decimal box. The number that goes in that decimal box is a 2, because watch. And there wasn't a decimal in this one. So that's why it's 2. And there's a 0 out in front. It's a runt. Just get rid of it. So essentially what I'm doing now is 35 times 94. Okay, do the math. 5 times 4 is 20. 4 times 3 is 12, plus 2 is 14. Put a 0 for place value because you're moving on. Cross out the things you don't need anymore. And now move on to the 9. 9 times 5 is 45, so you drop the 5 and carry the 4. 9 times 3 is 27, plus the 4 is 31. You drop the 1 and carry the 3. Oh, there's nowhere to carry it, so it just goes there. So I've got 140 and 3 150. So I add my partial products together. $3,290. But I have the decimal box. Remember how in the testament we forgot a simple decimal? 32.90. Could you just say 32.9? Yes, you could. Okay, so that was just a quick review of how to do multiplication with decimals. Everyone did super well in the multiplication test, so I'm not super worried about the multiplication, but it was good to review that. Don't forget, like on 29, when you do multiplication problems, you do the decimal box. Let's practice. The number that goes in that decimal box, go ahead and put it and then see if you got the right answer. If you said 4, you are correct. That is crazy. We haven't had one like that. So 4. Here's why. There's 2 there. So that makes 2. And then there's 2 here. So that was 2 place values. So 2 place values and 2 place values make 4. And this one's actually not so hard. We should just do this one really quick. Because look, these are zeros. This one's out in front, so it's a runt. This one's out in front, so it's a runt. And now this 0 is out in front, so it's a runt. So it's just 37 times 9, and then move the decimal 4 times. Let's do it. 9 times 7 is 63. 9 times 3 is 27, plus 6 is 33. All right. And then I move the decimal 4 places. Uh-oh, that looks like it's going to maybe be hard. How do I move it 4 places if there's only 3 numbers? I've got to put a 0 the hero. I have to put a 0 there to hold that place value. So it's 0.0333. That's pretty crazy. That is the answer. Pretty crazy stuff, right? Okay, for this last little part, we are going to be using these story problems. So I would love, actually I love all the work that we did on the other side. Let me see if I can zoom out here. Flip your paper back over to page 227. Never mind, we're just going to cut these ones out. 31, 32, and 33. Does that make sense? So here we go. We're going to cut right under the blue line. And we're going to keep the instructions that say mixed real-world applications. I'll show you here just a little bit. Push pause on your journal if you're needing extra time, but all I did was cut out 31, 32, 33. And then I'm also, just leaving, I left the mixed real-world applications, and then I cut that out. So I'm going to be putting this in my journal, just like this. And where I want it is over here on the right this time, as close to the 3-hole punch as you can, and as close to the top as you can. And go ahead and get that glued. Wow, if you're wondering what that was the can of fate. That's exciting. Anyway, go ahead and get that taped in here and glued. And now all your lovely little names are all over the floor. That's fun. When you tape or glue it, make sure that you don't put tape or glue over the holes, because then you won't be able to put it inside of your binder and stuff. Okay. Push pause if you're not caught up to where I'm at. Take your red. We're going to highlight what's important, and if we decide that it's multiplication, we'll use green. If we decide that it's division, we'll use yellow. Here we go. Polly bought 12 beach balls for her beach party. She spent $23.64. How much did each beach ball cost? She bought 12, that's important. This is the total that she spent. How much did each cost? If you times those two together, 12 times that, you're going to get a really big number. And is that reasonable? No, she only bought 12 beach balls, so it's not going to be over $200. So if I say how much did each ball cost, I take my total and divide it by the number I bought. So this is a total divide by number. Let's write purchased. That's a better word than bought. So I take my total and divide by the number purchased. So I'm going to use yellow for division because it's saying each and cost. And this is definitely division. Okay, let's do the work for it on number 31 to the left. So I take the total amount, which is $23.64. And I divide that by the number that she bought, which was 12. Notice that I put my decimal right on the line. That's going to help a lot because there's not a decimal in my divisor, so I move the decimal in the dividend straight up. Okay, does 12 go into 2? No, you place a little x. Does 12 go into 23? Yes, it goes only once. That's crazy because 12 times 2 would be 24. So you subtract 23, you subtract 12 from 23. Or you say 23 minus 12, which is 11. And you bring down the 6. You should know your 12 times tables. How many times does 12 go into 116? Should be 9 times, and that would be 108. You subtract that. And minus 10 will be 0, so it's just 8. Bring down the 4. And how many times will 12 go into 84? Exactly 7 times. So, how much did each, let's use yellow here, how much did each of the beach balls cost? That seems way more reasonable. Put it in a complete sentence, $1.97. So each beach ball cost $1.97. Number 2, pick up your red. We'll only use green if it's multiplication, and we'll only use yellow if it's division. But we'll first highlight the important stuff in red. The 245 fifth graders are going on a trip. That seems important. Each van can carry 16 students. How many vans will be needed for the trip? Oh, here it is again. Each van can carry 16 students. So how many vans will be needed? This is, go ahead and take a guess with your operation off to the side up here. Oh, I just wrote it. I'll hide it. Make sure you can't see it. Is it divide or is it multiply? Think about it. You have this amount of fifth graders and they're carrying 16 students each van. So how many vans do you need? It's division. Sorry about that. I'm going to actually underline van. So this is another division problem. This is always interesting because it's asking you how many vans will be needed for the trip. You can't leave any students out. Okay, so we're just going to write this. No one gets left out. So when you divide this, if you end up with the remainder, you have to think about what to do with that remainder. Okay, let's set it up over here to the left. 245 divided by 16. $16 won't go into 2, but it will go into 24 one time. Subtract that. Bring down the next one. How many times will 16 go into 85? I don't know. I don't know my 16th timetables. But 16 can round to 20, or it can be close to 15. I'm going to go 20. You could do 15 if you want, but 20. 20, 40, 60, 80 would be 4 times. And 5 times would be 100, which would be 15 off. I don't know. Should we try 4 or 5? Let's try 4. I got 64. Oh, it should have been 5 times. I think you could get 16 more out of that. Dang it. Do 16 times 5. Yep. 16 times 5 is 80, so it can be 5 up here. Bring down the next number. Oh, there's none to bring down. So if I have 15 vans, I'll leave 5 students out. So what do you do in this situation? I'll show you. Connect it here. All the way to this arrow. No one gets left out. So we're going to write on this yellow line, you must use one more van. You must use one more van. So you can't just do 15, you have to do 16 vans. So no one gets left, we'll say left behind. Okay, so this is you really thinking through. If I said I needed 15 remainder 5 vans, that doesn't make sense. If I only put 15, I'll leave 5 kids out. So I have to have 16 vans up here. But will there be extra space? Yeah, I'm going to write that in parentheses. Extra space. Maybe not all of the buses will be all the way full, or maybe one will just be almost empty, but you're going to have extra space. All right, number 33. This is our last problem we're going to work on. You ready? Today, Aaliyah, I don't know, ran 4.5 miles per hour for 3/4 of an hour. How far did Aaliyah run today? Okay, this is interesting. So she ran 4.5 miles per hour. That's like how fast she was going. But she only did it for that amount of time, or 3/4 of an hour. So she didn't go a whole hour. If she went one whole hour, she would just have gone 4.5. But she didn't. She went 3/4 of an hour. And this word here is really critical. Of an hour. That means, my friends, that we are going to be taking a piece of the 4.5. So this word right here, critical to which operation? Multiplication. That one is multiplication because she only went 4.75 of an hour. Okay, so we set this one up. 4.5 times 0.75. Uh-oh. Longer number on top. So you're going to rewrite it. 0.75 times 4.5. That is really important to remember. This case, it kind of didn't matter, and you know we did that earlier, but it didn't necessarily matter but I still think it's a good skill to practice. Okay. Well, when you're multiplying or taking a piece of 4.5, it's going to be less than 4.5. She's not going to run 4.5 miles per hour if she didn't even run an hour. So it's going to be smaller than 4.5. I'm going to start with a decimal box. The number that goes in that decimal box is a 3. Watch my pencil motions to make sure that you know how to do it to get the 3. You see the 2 and then the 1? Okay, there's a 0 out in front, and it's a runt. Cross it out. Looks like a number 1. I really need to cross it out. Okay, so now it's just doing 75 times 45, and then we'll put the decimal back in. Go ahead and do all of that math, and we'll catch you at the end of it. Did you get a 3375? Okay, but now we have to put the decimal back in. Move it 3 places. There it is, 3.375. So how far did Aaliyah run today? She ran 3.375 miles today. Okay, that was a lot of work and a lot of practice, but you can totally do this. So when you get your homework in remembering side, make sure that you put your name and number on it. But you are going to be left to your own to do this, and it's a lot to do. So be careful. Let's look at number 12. I'm going to help you out with a color. And I'm not going to say anything about what the color means. You're going to have to use your journal to connect it. Harriet makes yo-yos. She needs 38 inches of string for each yo-yo. How many yo-yos can she make with this amount? How many inches of string will be left over? The fact that you have the phrase left over in there should tell you automatically what this operation is. Okay? Use your journal to figure it out if you don't know what the color yellow means for what operation it is. 13. Roberto will save 1/6 of his allowance each day. If he gets $2 a day, about how much money will he save each day? So he saves 1/6 of the $2. My friends, come on. The word of right there should tell you this. Round your answer to the nearest penny. So when you get to the end, you're going to have some decimals probably, and then you're going to just round it to the nearest penny, which is the hundredths place value. So round to the nearest hundredths. And raisins cost this much per pound. Michael bought $15.52 worth of raisins. How many pounds of raisins did he buy? So we know his total, and we know how much it was per pound. So guess what, my friends? This divided by this will tell you what to do. Well, that's what I'm going to do to help you. If I were you, I'd start with numbers 12, 13, and 14, and then I would just go to the quick practices. On 1, 2, and 3, it's just mental math and you moving decimals a certain number of places. So don't panic. You can do it, like number 1. 15 times 5 is 75. But then I had 1 decimal place, so it's actually 7.5. Number 2, 4 times 5 is 20, but I have 1, 2, 3 decimals. 1, 2, oh. So it's 0.020. Next one, 4 times 3 is 12, but I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, that's crazy. But those are super fast. The next ones you're going to actually have to solve. And then on the remembering today, you don't have to do stretch your thinking. And I'm going to let you, because you hung in there so well, if you put a red box with a yellow star. You only have to do the odds. If you don't have the red box and yellow star, you have to do all of it. Thanks for hanging in there. I hope you had some fun with deciding whether or not we're multiplying or dividing. Good luck.